Hey there, Pam. Welcome back to the Making Math Moments That Matter podcast. We had you. It's been a while. You presented in a few of our Make Math Moments virtual summits over the years, but stretching back, I think it was episode 71, which is a while ago because this is episode 255.
Woo.
So, it's been a while that we've chatted with you here on the podcast. We thought, hey, we got to bring Pam back. How are things going in your world?
Well, I'd like to thank you guys for having me on. You guys do a fantastic job. I don't recommend too many people carte blanche, but you guys are on my list. So you do an excellent job. Thoughtful people, and I really appreciate that you think about what you're doing. That's excellent.
I love it. I love it. We always love running into you. I know the last time I saw you, I think in the flesh was, I think last year, what, NCSM maybe or something?
I believe it was NCSM. Yeah.
I think
we ran into each other at a restaurant.
Yeah, we were at the restaurant. We were out. And then, of course, we had some laughs that evening, hung out for a little bit. And then I got to check out your session as well, which I, again, always love your approach. You're real. And it's always great to catch up with you. So, hey, tell the math moment makers, like, what the heck is new in your world? I mean, has math changed since the last time we talked, or like, is it still figureoutable? Tell us about that.
Math is still figureoutable. Very much so. Yeah. There's maybe more and more. I've part of what I've done is I started as a high school teacher and thought I knew high school math. And then, really got into technology and graphing calculators and was able to play around a whole lot more with things and kind of test conjectures. You can't do that when you're rote memorizing and spitting out rules, which is what I did as a student. And so I kind of figured out secondary math more so, and then had this huge experience where my own child was growing up, really my own kids, but my oldest for sure, was blowing my mind with how he was thinking about math. And I'd never thought about math that way. And I didn't understand why he wouldn't mimic the teacher. I was like,
right.
What are you
Better
doing?
do what he says.
Like, yeah. He's like,
isn't that the right way to do it? Like, that's the way you're supposed to do it.
Isn't that the only way to do it? So that when he would invent his own, I was like, that's not a thing. Like, you don't do that in math. And so that sent me into the research, like where I could really, I was sort of curious, can you teach arithmetic differently? Can other people do what he does? Can we actually teach kids to do that? And we can. And I know you know that, but it was a world, a universe opened up to me in younger math. And so then I kind of became an expert about building numeracy. And from someone who had no numeracy at all, then, I learned to think and reason myself about numbers. And then I kind of grew up with my kids, learned to think and reason additively first, and then multiplicatively. And then I built my own proportional reasoning. And then I looked at secondary math again, high school math especially. And I was like, whoa, I thought I was really reasoning about math. And so a current interest of mine is that I'm really diving into, I've just done a whole thing on linear functions. And I'm really diving into exponential functions and the connection there. And then I'm going to go into quadratic functions. And I'm just really thinking about sequences of tasks. So tasks. Sorry, I said that fast. Which I know you guys are interested in as well. I think that's one of the frontiers is we've kind of had textbooks. We've kind of had then some textbooks gave a shot at, sequencing things, but not the way we are now.
Right.
And I think that's a bit of a frontier to really think about having an open enough task that everybody can enter, but that everybody grows from. And then what does it mean to have the next task that everybody can still enter and can still grow from? And then what's the next? And I'm super interested in that. In fact, I was listening to one of your podcasts this morning, and one of the conversations was, like if you have a student who's absent for a week, how can you make up the learning? And one of the thoughts that I had in that moment was that's one of the things I'm seeking for is not that I necessarily have something to hand that kid, but that I'm actually teaching in such a way that he folds kind of naturally in because there's a place for him to enter where he is. And we're going to keep cycling back enough. Anyway, I'm kind of doing high level. Anyway, that's one of the things I'm currently thinking about.
I love it too, because we've like your task that you're describing, we've built our task so that day two is like a little bit of a math talk at the beginning, which has got some skills from day one. It's students are naturally folding in, whether they've missed a day or maybe even 2 days, they're coming into that because they're so low floor. So what would you say? Like, it sounds like you've done a lot of thinking over the last little bit. What would you say is the most surprising thing you've discovered in the last 12 months?
Whoa, John.
Wow.
That's a big
Hit me with a good one.
Yeah.
How many surprising?
Yeah, just something that was like just blew, like it was like, man, that was just, that was shocker. That was just, I wasn't expecting that.
While
could
Pam's
be
thinking about
yeah.
it, I'm gonna give an example. Yeah, that was like, I mean, it's a great question, but
I have three things, but I don't know that any of them are what you're talking about. But go ahead, Kyle.
Anything.
Well, I was gonna say, like, when I started to play on the number line and it was funny how you described it, because you were talking about additively, then multiplicatively, then like, proportional reasoning and your proportional, understanding of proportional relationships. When I started to do that on a number line, and like over this past year, and really went down the rabbit hole of solving systems of equations in different ways on a number line, where the type of division actually is like where the context drove the type of division that you were using at the end to get rid of the coefficient, that blew my mind. Like that, I was like, oh my God. Like, it's like, I can tell you that because of this type of division, that it's going to look like that on a double or on a number line. And you're going to use that strategy. And if it's that type of division, then you're going to do this one over here. And it was like, that to me was like, mind-blowing experience, and took a long time to do. So you said you had three, but at least share us one. What was one that maybe like, as you're, I think what John's getting at is like, when you're going down this rabbit hole and you're trying to keep tasks like low floor enough, it's almost like you want them to be almost like wide, where you have this big idea that you want to focus on, but the task allows for this width so that some of those students who miss some can still enter. And then the students that maybe are like a little bit further ahead than others can still like continue advancing. Like everybody's benefiting there. There's got to be so many things that, you kind of bump into and you go like, oh, like I didn't recognize that, or I didn't realize, or maybe I didn't see how important that one thing was.
Yeah. And that's the beauty of math. If we're doing what I call real math, for really mathing, there is that interconnected deep, like things over here that maybe not everybody's going to get to, but it's open enough that the kids are ready for it, have that experience, and the kids who aren't ready can have another. Yeah. All right. So I'll choose one.
Yeah.
One that's on my mind right now is you guys know, your listeners might know, I'm really interested in problem strings as an instructional routine. So I think problem strings are super important and very helpful in helping kids really math, helping the average student know the way that mathy people think, and the way that mathy people kind of learned relationships maybe on their own. We can do that with all kids, and a way to do that is by using a string or series of problems to teach. Well, so lately, we as a team at Math is Figureoutable have been talking about structures of problem strings. And I'll give a lot of credit to Cara M. and Rachel Lambert, and her name will come to me in a minute. I'll come back. They did a session 5 years ago or so at NCSM, I believe it was, about problem string structures. And I kind of hadn't thought about it, and I've kind of left it alone since then. I've written a lot of problem strings, but we're currently writing at our team here, we're writing a K-5 series of problem strings. So there'll be a third grade problem string, a fifth grade problem string, a kindergarten problem book of problem strings. And as we've been writing them, we're realizing that it really informs what we do. So when we say to ourselves, I want to talk about this strategy, this main strategy for multiplication. How can we really help kids develop the relationships necessary to be able to do that strategy as kind of a natural inclination? And then it's been super helpful to go, do we want an equivalent structure? What does that mean? That means where the problems in the string are equivalent to each other. So an example might be, let's see if I can give you a good one, where I might say the first problem is 15 times 18. Go. Students solve 15 times 18. I may share a couple of strategies. It's a rich problem. There's lots of nice strategies. Of the 5 main multiplication strategies, you can use 4 of them, at least, maybe even the 5th. I have to think 4 of them to do that. So I might share a couple of those. And then the next, so 15 times 18, the next problem might be 30 times 9.
Ooh, I like it. Doubling and halving.
And so you want kids to go, same answer. And the teacher goes, probably just a coincidence. And then you give another problem. And at this point, depending on the numbers, and I don't have it memorized, but you might give a third one that's equivalent if you have it. So let's see, what did I just say?
Yeah, like 60, time. Well, I guess.
You'd have to go 4.5.
But yeah, but it would work.
Or go the 4.5. Yeah.
Yep.
So now you have another equivalent. Now that you would probably not do that in 4th grade, but you can do it 5th grade or 6th grade. And then you might do another set of 2 or 3 that are equivalent. And then you ask students, what's happening?
Yeah.
So that's a structure in a problem string that kind of allows some things. In fact, that equivalent structure is the one that we now have realized you use to help students develop equivalence strategies. What do I mean by that? Strategies like doubling and halving. An equivalent strategy is I solve the problem by creating an equivalent problem that's easier to solve. So another example might be if I have something like 72 minus 37, I might say to myself, I don't want to solve that problem, 72 minus 37. I'd rather subtract 40. So if I think about the subtraction problem as the distance between those numbers, I'd rather solve an equivalent problem that, what I say, 72 minus 40, 37.
Yep.
So if I bump those up both by 3, then I would end up with 75 minus 40. Bam, an easier problem to solve. That's an equivalence strategy. So the shocker for me was, hey, to help students develop equivalent strategies, you use an equivalent structure of a problem string.
Right.
Kind of cool. So there are other structures of problem strings.
Very cool.
Do you want one more? Do you want one more structure?
Well, you know what? Before you do, I do want one more, but I want to make a comment too, because I think it's interesting in the first string that you use, because you were doing it off the cuff, like off on the fly, but it just shows how important too, when you design a problem string, what's really interesting, what I think is really valuable, you'll notice on our, in our problem-based units, our math talks are problem strings as well. And some are, structures that bring out this equivalence idea. Some are just seeking out a different behavior in the math. Whatever that purpose is, the goal though is that as you design it, you would have probably in 3rd grade, like you said, you went 15 and 18. You're like, okay, that works. And then 39, that works. And then you went 60 and 4.5. And you're like, I guess I'm going to adjust that first one. And I'm going to go back and I'm going to fix, you know what I mean? Like, so it just shows how with a problem string, all of the numbers, at least in a chunk, because sometimes the string might be long and then it might be in different chunks and some might be related and some might not. But when you do that, it's all about that intentionality. And like you're saying, it's like, you want kids to almost like bump into it. Right. And I loved your sort of nonchalant, I do that sort of thing all the time where you're just sort of like, that's weird or that's odd. And it's like, I like how you said, must be a coincidence. Like, I've not used that one, but you use some of these ones where you're talking to the kids and it's like you're playing it up like you have no clue what's going on, when in reality you thought long and hard about this exact string and why I'm doing it and when I'm going to say this, and it's so helpful for kids.
We just did one that we were just talking, Kyle, in our live Q&A session last night about working with exponents and the exponent laws and thinking about the quotient rule and how normally for a long time I just taught the rule, right? It was like, hey, here's the rule, use the rule, and then
Follow
it was
me.
like then these carefully crafted strings where, hey, when you simplify this, or kids would just normally like crunch the numbers with their calculator and like put to the power of, but they all came out to be 1. It was like 1, 1, 1, 1. And it was like, oh, must be a coincidence that, 3 to the power of 4, divided by, 3 squared times 3 squared is 1. Like, that's weird, like, it's just like everyone was 1. And it was like everyone's starting to go like, something's up here. Let's explore why it's always one.
Let's
build ones.
Mr. Orr is pretending like he doesn't know what's happening again.
Very nice.
We have a super video of a string very similar to that, where the teacher's walking around as the students are doing something, and her name is Abby Sanchez. She's an amazing teacher, and one of the students on camera goes, "Look at that look! She's doing it again." She had this look
Yeah.
Yeah. She always had that look on her face. And it's brilliant because we have the kids saying it, and then we have the camera on the teacher going,
Right. Awesome.
Kind of an inquisitive, kind of like you're curious with them. Like Kyle, you said a minute ago, you kind of like I'm kind of clueless.
Yeah.
You can pull that sometimes, but you can also pull like you think, like, let's dive into that. Like, I'm curious about that too. Like, what's happening?
Exactly. You think like you think that there's like a pattern happening here. That's interesting. And it's like, you know what I love about math is that it's all about patterns. Like there's, it's like, what do you notice? Like, what do we see here? What's going on? Is this related? Is this not related? Or how is it related? Or maybe there's more to the story, You said you had one more. I want to make sure before we segue, we've got a segue idea here to chat with you about. You said you had one more string for us. So hit us.
Yeah. So one more structure. I think we've identified about 5 structures. One of the other structures that we often use, it's a typical one, we call helper clunker. I think we got that term from Kathy Fosno, maybe, where you give a helper problem and then one that's harder to solve, but you could use the helper to solve it. So for an example might be, give me an operation. If I was subtracting, I might say something like 42 minus 20.
Yep. And then you start off with the lob ball. I call it like, throw the beach ball.
Yeah.
And then it's like, and then you throw the curve.
So 42 minus 20, 42 minus 19.
Yeah.
73 minus 30, 73 minus, and then I pause and people will go like
29.
And I'll say close, 28.
Yeah.
You're like, oh, like one
exactly.
off. Yeah. And you keep the kind of spark alive. You don't want it to be too predictable.
Right.
But I want to say one other thing before we leave this. Problem strings, like you said a minute ago, you're super deliberate in the design. One of the questions I get asked a lot is, "Hey, Pam, teach us to write problem strings." And we do that in my Journey membership. We talk about how to write problem strings, but the first step is do someone else's pre-written problem string. Yeah,
absolutely. And like that's how
what it means for how the facilitation works, why they wrote it the way they did. Like
100%. And you know what? It's like one of the reasons is not only because you then get to experience and see these different structures, these different approaches, but like one of the other things is like you're going to learn a lot. Like that's I think the reality. I learned so much when I started doing problem strings. And you'll notice in this conversation, for those listening, hopefully there's more than just the 3 of us listening right now. Hopefully more will listen. I'm sure there will be a handful that will. Those who are listening there, Math Moment Makers, you'll notice like we do talk a lot about how like, there's number talks, there's math talks, there's, some people just think of them as warm-ups. Like minds, like there's all these different terms, but like a problem string to me is so specific and so important and so intentional that it's like you're helping to emerge these ideas, which oftentimes were like things that you might have maybe like like it's like, oh, that's obvious that was true, but you never thought to use them to help you to solve problems. And that for me was like a big epiphany, especially when doing, say, subtraction problems like you just gave us there, where the nice little fastball down the middle and then the curveball comes. That for me was like a big epiphany and going like, wow, like I didn't really like, I would have never used that strategy. I would have always used like my go-to strategy. And this is one of the other things that I didn't recognize for a long time, but is really important when we do math talks. And I think this is going to be a great segue to start talking about your summit session coming up in November. But when we do number talks, oftentimes what happens is, and I noticed this was happening for me, is I would do a number talk and I would ask students to solve these random problems, oftentimes disconnected, not structured in a problem string sort of way. And what you'll get is you'll get kids sharing various strategies, and you almost get students where like they think the goal is to be as creative as possible instead of actually trying to be, I use the word efficient, but more or less like looking at what is happening and use what's happening to their advantage. And what you find is, if you actually pay attention, is you'll start to recognize that kids start to sit and they start to use the same strategies over and over and over. And sometimes those strategies in scenarios that are not actually helpful, like that they're actually like hard and actually making it more hurtful for them to use. But if we just have like sort of like this loosey-goosey number talk that everybody's just sharing whatever, instead of having something intentional, what I recognized after doing problem strings was like, you know what? I'm going to let you solve the first couple problems with any strategy you want. That's like the low floorness of it. But now I'm going to push you to try this new one. Like we're going to hone in on this new one. So if you didn't fall for, like you were saying, you know, doing the 72 minus or 42 minus 20, then the 42 minus 19, like the adjustment, like that's a strategy we're trying to get them to do. If they're not doing that, then it's almost like you want to be explicit, or at least that's what I would want to do. I go, okay, now I want to challenge all of you to try this new strategy. How many people can see this strategy is working? Amazing. Awesome. You've recognized it. Now I want you to actually do it, because unless you do it, you're just kind of using the same old, you know, wrench out of your tool belt, right? Like you're pulling the wrench out every single time, no matter what. It's like, I want to give you another tool for the tool belt. You don't have to love it and you don't have to use it all the time, but there will be times where you go, you know what? That one's actually a whole lot easier to use than this one over here. What are your thoughts on that? Like, do you always have an intent to make sure that we elicit this specific strategy? Are you kind of, sometimes you're like, let's just kind of let them go? What's your thinking on that?
So if it's a rich task, then it's a bit more let them go.
Yeah, for
If
sure.
it's a
I
problem
agree.
string, yeah, if it's a problem string,
you've got intentionality.
Yeah,
and
for sure. Let me tell you my two favorite ways to make it happen. So Kyle, your way's a fine way. My two favorite ways is as we're going through the problem string, I might say, did anybody use the problem before to help you? And then I might look, and if no one did, or if a few students didn't, I might say, could you?
I like it.
And then
kind of that push,
yeah.
Right?
And so even if they didn't, then I'm going to say, all right, so you solved it any way you wanted. Did anybody use the problem before? I'm going to point out. I'm like I'm flashing. Did anybody use the problem before? And then I'm going to like, could you?
Yeah.
That's one method. A second method is I'm going to be circulating as much as I can. I'm going to be seeing what kids are doing. And then I'm going to say, sorry, I've got too many things in my head right now.
Is this part of it? Is this part of the routine? She's like, you know, like where you're tricking the kids. Like I got.
let me choose the way I'm going to go. When I see kids, like you said, that are kind of stuck, they've got a way, they've got the answer, then I might say to that student, did you understand John's strategy? Yeah. And they're like, well, I got the answer. And I'm like, well, right, we all had the answer. My question was, did you understand John's strategy? And they're like, oh, I wasn't listening. Then I'll say, oh, well, you can go ahead and ask John. Like it's okay. Go ahead and ask John. Like real, and then I will like do everything I can with all of my go turn and ask John. Fine, John, how'd you do it? And then as John starts to explain, I'll be watching that kid. And when that kid's like, then I'm like, oh no, you actually have to listen to John, because I'm going to ask you. I'm going to ask you how John did it. And they're like, no, I told you I already got the answer. And I'm like, well, that's not what we do here. What we do here is we listen to each other. This is a good segue into my.
Yeah, it is.
You see where I'm going with that?
Yeah.
We listen to each other, and our job here is to understand how each other are thinking about it. And John used the problem before. You didn't have to, but he did. And so can you use that? Can you explain what John was doing? So that's a way to get it to be a little bit less of, all right, everybody, do this strategy. Like, I'm going to command you now to do it. I'm going to say, no, you can do it any way you want, but you have to understand how John was doing it. So can you explain how John was doing it? I don't care how you did it. Like,
that's the other piece too. Like I'll say something very similar to that as well, where it's like, you know, when someone shares and, you know, having that pause moment and asking everyone saying, I'm not interested if you did it the same way. Do you see how John did it? Do you see how John saw it? Do you see how John approached it? And it's all about like, again, it's like not about us mimicking each other. Like that's not what it's about at all. It's like, if you did it a unique way, amazing. We might share, but today I really want to hone in on John's method here, and maybe you're a thinker like John, but if you're not, guess what? We're going to try to help you think like John, at least in this moment. And maybe it'll help you in a future scenario where you're dealing.
And then you have choices. Like all too often I hear teachers say, no, this kid's got a way. We're going to let them do their way. We're going to honor their thinking. And I'm like, whoa. I honored their thinking because when we started off, we let them solve it any way they wanted. That we honored their thinking. Now we got to move the math forward.
Totally.
Want to help them have choices. So like you said earlier, we don't want kids sort of stuck in one method of thinking.
Getting really good at one way versus being really good at like multiple ways is like, there's like flexibility, right? Is like what we're after here. We want to get you flexible and fluent.
Well, I think that's perfect to talk about, your session, Pam, because if I want to talk about intentionality for a sec, like when you're saying like, this is what we do here in our class, and these are the things that we want to emphasize. And it's not just about like doing the thing that everybody wants to see. Like, oh, I got discussion in my class. My kids are talking, but are they talking about the strategy? Are they talking about the math? Are we pushing the math forward? Like that is a really important distinction, I think, about like making sure that we're engaging our students in say discussion, but also we're making sure that we're helping them make that connection to mathematics, that deeper understanding to mathematics with strategies and also in models. So your session coming up in our summit that's happening in November is Let's Talk About Talking. And it's perfect because I think like what I just said is that lots of people think we should get our kids talking, but it's like, well, how do I do it? And like, what are the most useful strategies to get my kids talking? And if they're talking in class, is that good enough? Or like, what is the best form of talk? Fill us in on some of the insights that were maybe why you wanted to do this session at the summit.
Yeah, absolutely. So I'm going to tell you a quick story. When I was a high school teacher, hot minute ago, there was a movement in Michigan to write across the curriculum. At least it hit sort of my school big and hard. And we were supposed to write across the curriculum. And these were in the days where I was still really pretty stuck in what I would call fake math. Math was about mimicking. I was trying to help kids. We had lots of songs and rhymes and raps because if you're going to memorize stuff, I want to help you memorize it well. And in that mode, we had to write. So everybody was supposed to write in classes.
Like journaling?
Like produce a written product. Okay. And I in fake math land, guys, I had no idea. I was like, what in the world are they going to write about? So it's, to me, that is a very similar question to why are we talking in math class? If make math moment makers, that's what you call your guys, right? Math
moment makers. Things. Lots of M's. Yeah.
All the M's. I would invite you to consider that if you think about math as a disconnected set of facts to memorize and rules and procedures to mimic, then the question what to talk about is, I think, super tricky. Like I thought, what is there to write about? But if math is about using what you know, relationships and connections you own, to reason through things that you don't know yet, then there's lots to talk about.
I love it.
So one of the interesting experiences I had not too long ago was we were working with a small school, and we were working with a small group of the teachers in that school. And as we were working with a small group of teachers, we worked closely with them. They were getting phenomenal things happening, like lots of good conversation in their classroom. They were also telling their colleagues the activities they were doing. And so the colleagues were getting the activities, the tasks, but without any of the experience themselves about actually doing the task and realizing what it means to math. So kind of this secondhand thing, as we went in and we were kind of working with the teachers that we were working with, one of the teachers said, will you go and just kind of check out how it's translating? Like, what's it looking like in the classrooms that aren't part of our does that make sense? They're not part of our community.
Oh, yeah.
Yeah.
I'm going to guess it looked different.
Yes, it looked drastically different. And
Yeah.
the one that I want to paint, the picture I want to paint for you is I walked in and I sat in the back, really liked this teacher. It was a very the kids liked this teacher. You could tell it was just a really good human being. There was lots of good sort of karma in the class and everything. And then math started, and the teacher would walk up and down the aisles and was doing one of our tasks. And this is how the teacher heard productive struggle and talking in math class. The teacher said, "Nope, not yet. Keep going." And then moved on to the next kid. "Ooh, close. You can do it." And then moved on to the next kid. And it was like this. It was the difference. Here's how I've kind of described it. I felt like I was listening to a cheerleader, not a coach.
Interesting. Yeah, like cheerleaders don't really actually help the team do anything better on the field.
I mean, they get you hyped up. There's some energy.
They help the fans get excited.
Yeah, that's a good analogy. A good analogy. And you know what, though, I will say this, though, is that the fact that I'm gonna guess based on that picture you painted for me, that teacher probably wouldn't typically teach with a task usually. So that teacher was probably so uncomfortable going like, how are they going to do this when I haven't taught them everything yet that they
don't know how to
know?
They don't know how to do it. And they're supposed to guess what's in my head. So I'm going to cheer them on while they're guessing.
Yeah, like I'm just hoping and praying here, but they don't have the rules and the algorithms and all the things that I normally would give them ahead of time. And on the other end too, the kids are probably trained, as many are, that's how math class happens. So like they have this belief that, I mean,
and experience.
It's a reality. It's this is what math class is for me. And that is like, that must have been such a awkward situation to be in, right? Like I've been there. I know exactly how that is. And it can be so difficult because like as a mentor or a coach, you're there and you're sort of like, where you can't really go very far without like sort of going, hey, like, can I hop in? Which is, potentially offensive, right? But that is really, really interesting because in your session, you're going to be essentially talking about exactly that. And I feel like through our discussion with problem strings, but then also through a task-based approach to teaching, right? Whether you want to call it problem-based lessons, whether you want to call it just, hey, we're going to solve through task, whatever you want to call it. The reality is that the talking is all about the reasoning, the conjecturing, the estimating, the wondering, just all of those pieces make real math discourse sort of happen. And there's still a lot of teacher moves and facilitator moves required in order to navigate that world and keep that flowing, do all of those things dynamically. But ultimately, at the end of the day, it really makes you wonder if our goal is that we're going to teach those rules and procedures, like you said, and that's sort of how we're going to do it. We're going to mimic it. Talking is almost like a bit of a waste of time because unless the kids are just going to recite it to each other so that they can memorize it better, right? But ultimately, you're kind of wasting time getting to that goal of just memorizing a bunch of stuff. Whereas on the other hand, if students are actually talking and inquiring and they're trying to like see how somebody else sees it and they're modeling it and showing strategies or demonstrating strategies, like that's true mathematical discourse. So if someone's listening right now and they're like, hey, Pam session is going to be on Saturday, November the 18th. It's going to be in the morning, depending on where you are, because people from all over the world are going to be joining in. But I think your session's around 11 a.m. Eastern-ish time.
It's 10:30.
10:30 Eastern. Awesome. So if you're on the West Coast, you're going to be looking at, it's a little bit early for them. I apologize to those friends, but we will also have those recordings going up after. So depending on where you are in the world, make sure you check it out. What would you say would be kind of like your big or your hope for the big takeaway that some of those participants are going to get when they come to that session called Let's Talk About Talking with Pam Harris?
Yeah, one of the biggest things to walk away from it are those teacher moves that you just talked about. What are the talk moves when we really want students reasoning? And I'm going to employ several of them. The first thing that we'll do in the session is actually do a problem string. And as I do it, I'm going to kind of enact it a little bit and call out some of the things that I would do. That's a short experience. I'd also like to help. I'm going to use principles to actions and the move of posing purposeful questions, the difference between focusing questions and funneling questions.
Okay.
So I have a really nice task. We're going to watch a video of an interaction of an excellent focusing pattern of questioning, and contrast that with a funneling pattern of questioning. So a funneling pattern is where you funnel a kid to an answer and kids got it. But if you remove that funnel, so the kid has a choice. They can either memorize your funnel or they're lost the next time they get there. But if you can use a funneling pattern of questioning, then students own that reasoning that they're using, and that they can then use that reasoning the next time and they learn from it. Those are probably two of the biggest things that are going to happen.
Awesome.
In the session. Yeah.
Awesome. Now, if a teacher comes to the session and they're going to get everything that you just said, what would you say is like prerequisites? It's kind of like, imagine like, what would I need to know? Like, what would I need to be able to be like good at, or like what should I already have experience in, or what might be a barrier for me as a teacher to get the most out of the session?
Are you giving the listeners homework before the session,
well,
John?
kind of. I'm trying to
right
exactly. It's like what is there something that's like I wanna make sure that I'm prepared enough so that when I come to Pam's session, it's like, hey, I'm ready to dive right in.
I would suggest I'm going to give you a short homework, John. So we're not going to like turn anybody off by giving them
No.
I would invite you to ask everyone you run into between now and then, partners of 100. So, and then your task is to listen and ask them how they think about it. So you're literally just said, hey, if we need 100 and I've got 83, what do we need? If we're total 100, what do we need to make 100? And then just wait. So if I've got 83, we need, wait. Let them figure it out. And when they say 17 back, you say, how do you know? And then your task is to just listen. I didn't know it was worth, I didn't know kids were thinking anything. I thought they would line those up and do some subtraction. Nobody does.
And some adults will too. That's the interesting part, right?
Some, especially if they kind of panic and math was all about mimicking the teacher and they don't, whatever. And then at that point you can say, I mean, you can do that, but I'm wondering if you could think about like getting up to 90, and then what would you need to get from 90? And pause. Yeah.
I love it.
So the more you can ask a fairly figure-outable question, and then the task to get ready for the session is then listen and open up to the idea that you can gain from how other people are thinking about numbers, and just see what happens when you try to nudge that person to tell you what they're thinking. And you're going to have some successful experiences where people will actually tell you what they're thinking. And you're going to have some experiences where they're going to say, oh, I was never good at math and I don't know. And then how do you handle that? Like in that moment, what kinds of ways can you help settle their anxiety and help, like give them just a nudge for reasoning, kind of like when I said 83 and well, can you get up to 90?
Yeah.
Do you know the part 80 to 100?
Yeah, I was just gonna say, I'm like, or like, do you know 80, or does 85 make it easier for like whatever, right? Which super cool.
And pause in between each of those and give them a chance, and give you a chance in a low stakes environment to get better at eliciting thinking.
I love it. So something we talk about all the time in math classes about like listening and observing, and like you giving this very manageable homework before your session, I think is going to be so powerful for those who are listening and those who actually take you up on that offer. Because when you go down the rabbit hole with them in that session, you know, they're going to have all that experience, right? And everything is so much better when you have the experience in doing something yourself. Hint, hint, just like our students gain, you know, more experience, more value when they're doing math themselves and actually reasoning and proving through it. What a cool way to set up for that session, which once again, friends, is going to be at 10:30 a.m. Eastern time on Saturday, November 18th with Pam Harris. She's going to help you show or understand or believe that math is truly figureoutable. Pam, for those who are curious and want to maybe do more homework, maybe exploring more about Pam, where can they find you? What else do you have out there that they might want to explore in the meantime as we look ahead to the virtual summit coming up in just about a month?
Yeah, absolutely. So mathisfigureoutable.com has all sorts of free resources. You can click on the at the top of the thing, it'll say free resources or learn now. Lots of new, I shouldn't say new, but some new, lots of free problem strings. We also have other instructional routines.
Awesome.
I call it as close as it gets, and relational thinking, some kind of opener, quicker problem talks are nice. So mathisfigureoutable.com. And announcing the day this podcast drops. So you guys told me, October 16th, 2023, I am opening a brand new mini workshop called Teaching Place Value. We recognize that place value so often in most of the resources looks like place labeling. Which is necessary, but not sufficient. Like, and we do all the work to do all the stuff that's called place value. And then we're like, guys, kids don't even know place value. And so I would suggest that's because really that work was all about labeling places and not really helping students to
not really valuing what place value is all about.
Yeah,
exactly. Yeah. So
I love it.
This short mini workshop that we've got out, you can find that at mathisfigureoutable.com/mini, as for mini workshop.
Yeah.
mathisfigureoutable.com/mini is where you can find that. And you guys know I also have a podcast, so you can join me on the Math is Figureoutable podcast. That's a fantastic place. And I think we will see each other at NCSM, NCTM. So that would be fun if anybody wants to come and hang out there. As Kyle said earlier, that was a fun place. John, I know I saw you at a conference about a year and a half ago, I think.
A while, yep.
But those are always fun to catch up there. Those are
awesome.
Great.
Awesome stuff. Thanks, Pam. We'll put all of those in our show notes page, and the next time we see you will be in November, or before that, actually, be at NCSM. But after that, we'll see you over in November at the Make Math Moments Virtual Summit. So Pam, thanks so much for joining us here this evening, and have a great rest of your week.
Good night, guys.
Take care.